Here's the next example. Take the antiderivative of 7 over x cubed plus 8x minus 3 dx. First off, let's rewrite this with all the variables on the numerator and using rational exponents. So we have 7x to the negative third on the numerator plus 8x minus 3. We don't have anything in radical form as we did before, so we don't have to worry about that. And then we got dx. Now when we take the antiderivative of this, we're going to be applying this rule that the antiderivative of x to the r is x to the r plus 1 over r plus 1. So let's start simplifying this. We got 7 times, 7's a constant, so just keep it on the side, r plus 1, so that's going to be x to the negative 3 plus 1, divided by r plus 1, that's going to be negative 3 plus 1, plus 8 times x to the, this is a first power, so r plus 1 is going to be 1 plus 1, divided by 1 plus 1, minus 3. And then if you have a constant, then the antiderivative is just going to be the constant times x. So it'll be minus 3x, and then don't forget the constant of integration. Let's simplify this. So we have 7x to the negative second all over negative 2 plus 8x to the second all over 2. 1 plus 1 is 2, 1 plus 1 is 2, minus 3x plus c. Simplify this further, the negative exponent has to go to the denominator, so we have the negative moves to the middle, so we have negative 7 over 2x to the second power. 8 divided by 2 is 4, so we get 4x to the second power minus 3x plus c, and this will become our antiderivative. Okay, now here's a definition. The definition states that if f is any continuous function over the interval a comma b, then and f is the antiderivative of f, then the definite integral. So definite integral is when you go from a particular point to another particular point of f of x dx equals to f of b minus f of a, where the big F and the big F, these are the antiderivatives or the integrals of the small f. So here's an example. We want to find the antiderivative or the integral from 2 to 6. So the way we read this is we want to find the integral or the antiderivative from 2 to 6 of the function 5x to the fourth minus 2x cubed dx. Okay, so first off, make sure that all the variables are on the numerator. We don't have anything in radical form, so that's good. We can now move on. Now here's a notation for this. We put this in a bracket. Okay, we have 5 times x to the 4 plus 1 divided by 4 plus 1. That's by this rule that the antiderivative of x to the r dx equals to x to the r plus 1 over r plus 1. So we just have the derivative, the exponent here is 4, so 4 plus 1 divided by 4 plus 1 minus 2 times x to the 3 plus 1 divided by 3 plus 1. Don't forget the constant of integration c, and then that's going to go from 2 to 6. If we simplify this, we have parentheses. 4 plus 1 is 5, so I'm just going to simplify this. The 5 and the 5, they cross out, so we just have left x to the 5th power. 3 plus 1, this is 4. So if I reduce the 2 and 4, then it's going to be 2 goes into itself once, it goes into 4 twice. So that's going to be x to the 4th power divided by 2. And then we got the constant of integration c, that's going from 2 to 6. Now here's what this says. This says that if we have a definite integral that goes from a to b, then this equals to big F of b minus big F of a, where these are the antiderivatives. So this is now our antiderivative. Okay, the integral or the antiderivative is going to be this. So we're going to call this big F of x. And we're taking that from x equals 2 to x equals 6. So by this formula, we're going to take f of 6 minus f of 2. So in other words, first plug in x equals to 6, and then plug in x equals to 2. Now let me show you guys what this looks like, but we're not going to actually do it this way because it takes too much time. But if we were to, big F of 6, this would be 6 to the 5th power minus 6 to the 4th over 2. C is a constant, so there's no x there. Minus, now we're going to go to f of 2, so it's going to be 2 to the 5th power minus 2 to the 4th over 2 plus c. And what's going to happen every single time is the c and the negative c, they're going to cross out because it's just a constant. So we're really just left with this. So when we're doing indefinite integrals where you're going from a value a to value b, then we don't really have to worry about the c's because they're going to cancel out. Now you could put all of this in a calculator, but a faster way of doing this would be to put this in Desmos. So put this function in Desmos, put f of x equals to x to the 5th minus x to the 4th over 2 plus c, and then just put f of 6 minus f of 2. So put this in one line, not the 2 and 6, this is just for us to know. And then put this in the second line, f of 6 minus f of 2, and you will get an answer for this in Desmos, which is going to be 7104. Please actually do this and make sure we get the answer 7104. So pause the video, go through and plug all this in. Make sure you can get that answer. Next example, we want to find the antiderivative from 1 to 9 of 4x squared plus 2 all over radical x. Now first off, anytime you're dividing by a monomial, we split these up and divide them both by radical x. So I'm going to rewrite this as the integral from 1 to 9 of 4x squared, and radical x is x to the 1/2, so I'm going to rewrite that, plus 2 over x to the 1/2, and then all of that is, we're taking the dx. So we got the integral from 1 to 9. 4x to the 2 over x to the 1/2, we subtract the exponents. So 2, this is like, if we're doing 2 minus a half, 2 is like saying 4 over 2 minus 1 over 2, which is 3 over 2. So this gives us 4x to the 3/2. And we don't want to have anything on the denominator, so we want to write that on the numerator using a negative exponent. So that'll be 2x to the negative 1/2 dx. Now we want to take the definite integral of this. A definite integral occurs when we have an x value from start to finish, starting at 1, ending at 9. So let's follow the rule. We have the integral of x to the r. This equals to x to the r plus 1 divided by r plus 1. So the 4 is a constant, put that on the side. We have x to the r, which is 3/2 plus 1 divided by 3/2 plus 1, plus 2x to the r, which is negative 1/2 plus 1 divided by negative 1/2 plus 1. And then we're going to take this from x equals 1 to x equals 9. So we have to have that notation there. Notice I did not write the c. So the plus c, I didn't write that because I know that in a definite integral, it's going to cancel out at the end anyway. So for definite integrals, we don't have to write the c because we want a numerical answer. Let's simplify this. A lot of simplification to get done. We have 3/2 plus 1. 1 is like a 2 over 2. So this becomes x to the 5/2. Same here, 3/2 plus 1, which is 2 over 2. That's going to be 5/2 plus negative 1/2 plus 1 is x to the 1/2. Same thing on the denominator. Negative 1/2 plus 1 is 1/2. And this is again from x equals 1 to x equals 9. Now we can't divide by a fraction, so we have to multiply by the reciprocal. We're going to multiply by 2/5, multiply by 2/5. So the denominator cancels out. On the numerator, 2 times 4 is 8. So this gives us 8 over 5, x to the 5/2. Okay. Then we need to simplify the second one. Again, same thing. We can't divide by a fraction, so we multiply by the reciprocal of the fraction, which is 2 over 1. So on the denominator, this all cancels out. 2 over 1 times 2, that's just going to be 2 times 2, or 4. So this gives us 4x to the 1/2. And then we take the integral from x equals 1 to x equals to 9. And again, I left out the plus c because we don't need a constant of integration when we are doing definite integral, since it's going to cancel out anyway. Now, here's what I would do. Into Desmos, in one line, I would say f of x equals to 8 over 5 x to the 5/2 plus 4x to the 1/2. So now so it knows what f of x is. The second line, find out what is f of 9 minus f of 1. And when you do that, the answer is going to be 395.2. Okay, next example, we have the integral from 3 to 8 of 3 over x squared plus x to the 1/3 dx. So first, let's rewrite this with all the variables on the numerator. So this gives us from 3 to 8 of 3x to the negative second plus x to the 1/3 dx. Okay. Now, if I take the antiderivative of this, again, we have x to the r equals to x to the r plus 1 divided by r plus 1. So this equals to 3 times x to the negative 2 plus 1 divided by negative 2 plus 1 plus x to the 1/3 plus 1 divided by 1/3 plus 1. And we take the integral from x equals 3 to x equals 8. All right, let's simplify this. So negative 2 plus 1 is negative 1. So we're going to have 3x to the negative 1 divided by negative 1 plus 1/3 plus 1. So 1/3 plus 1, which is 3 over 3. This gives us 4/3. So we're going to have plus x to the 4/3 divided by 1/3 plus 1, which again is 4/3. And we're going to take the integral from x equals 3 to x equals 8. Okay, let's simplify this. 3 divided by negative 1 is negative 3. Can't have a negative exponent, so move this to the denominator, becomes negative 3 over x. We can't have a fraction on the denominator, so we're going to multiply by the reciprocal of the fraction, which is 3/4. So we multiply the numerator also by 3/4, so the denominator cancels out, and we're left with plus 3/4 x to the 4/3. All of that is going to be from x equals to 3 to x equals 8. So once again, put in the function on Desmos, then figure out what is f of 8 minus f of 3. And when you put all that in, you should have 9.3799. So once again, please pause the video. Make sure you can do this. Make sure you get the correct answer. Okay, the next example we will work out in class. And the last example we're going to skip. So don't worry about this one. But this example we will do in class.